How do you give a community logo a powerful visual impact while staying time efficient? Today, we're breaking down the animation for the Mini Cooper community logo. I'll show you how I slashed modeling time using AI, built dynamic transformation visuals with geometry and shader nodes, and of course wrapped it up with the 3D to 2D reveal technique that has become my personal signature. Let's dive in. I'm using Blender version 5.0.1, so please adjust accordingly. Prepare the logo and car separately to turn your images into 3D models by visiting the smartest AI 3D model generator, Meshi.ai. Go to the Generate Image menu. Generate the car image into a sideways version. Add or drag and drop the separated car image. This will make the 3D modeling process easier. Click Image to 3D. Select the latest version of Meshi 6 and generate it to 3D. Look, this is amazing, the 3D Mini Cooper car model we wanted. Next, generate the texture. Once again, this makes it perfect along with the texture. Let's download and export it to Blender 3D. You can get this animated logo project file on my Patreon, and there you can download all my animated logo project files with just one subscription, and also find the full tutorial there. But if you want to support me by continuing to subscribe, it really helps me to always be enthusiastic about making 3D reveal animated logo tutorials. My Patreon link is in the description below. Okay, now let's continue. Import the generated 3D car into Blender, then rotate and scale it up. Enter edit mode, select the tires and separate them so we can animate their rotation individually. Choose the most perfect tire and simply copy-paste it to save production time. Separate each tire and automate their rotation using the driver feature. Now, add a keyframe to the car body on the Z-axis location and apply a noise modifier in the graph editor to achieve a vibration animation effect. We have a slight issue with the car textures not aligning properly, so let's fix it. Enter edit mode, follow the steps, and adjust the UV map positions. Don't forget to subscribe, like, and comment so that this channel can grow and produce more tutorials. Also join my Patreon community. You can download animated logo project files and other assets. Really appreciate your support. All right, that issue is resolved. Create folders to keep the layer management organized and make the workflow more efficient. We are now entering the stage of creating the opening transformation effect using geometry nodes. Duplicate the car and join everything into a single object, then reduce the polygon count with a decimate modifier so the transformation effect doesn't lag during preview. Now add a geometry node and an empty object which will serve as the controller for the effect. In Geometri Nodes, add a Distribute Points on Faces node to scatter random points across the mesh surface. Then add a cube to serve as a panel shape. Add an Instance on Points node to attach a cube to every point, connect them, and scale down the cubes. To make it less rigid, add 3 random value nodes, float, to generate random rotation angles. Then add a Combine XYZ node to merge those 3 values into one vector. Add an Euler to Rotation node to convert that vector into a rotation format, and connect the result to the rotation input of the instance on points. Check out that cool random rotation. Duplicate those 3 random value nodes for random sizing to make it more varied. Duplicate the Combine XYZ and connect it to the scale input of the instance on points. The result looks pretty great. To make it adjustable from the outside, add another Combine XYZ to merge X, Y, and Z inputs into a size value. Then adjust the sizes so they look like panels. Drag the empty controller into the Geometri Node setup to pull data from the controller object. Then add a Position node to get the position of each mesh vertex. Add a Vector Math Subtract node to calculate the position difference and connect them. Duplicate this math vector and set it to length to convert the vector into a distance value and connect it. Now we will create a ring-shaped effect area. Add a Compare node to check if the distance is larger than the inner radius. Duplicate it and set it to less than to check if the distance is smaller than the outer radius. Add a Boolean math node set to and to combine these 2 conditions into a ring selection. To ensure the controller's scale affects the ring size, add a separate XYZ node to split the scale into X, Y, and Z. Add a Math Subtract node to subtract the edge width from the expansion. Then add a Math Multiply node to multiply scale Z with the subtraction result. Also add a Math Add node to add the edge width to that multiplication result. In the object info, drag the input to the group input for easy access outside the panel. Drag the top value of the Math Subtract to the group input and name it Expand. Then drag the bottom value of the Math Multiply to the same Expand group. Drag the bottom value of the Math Subtract to the group input and rename it Width. Now you can adjust the expansion and width values. Don't forget to drag the density from the Distribute Points on Faces to the group input. Do the same for each axis of the Combine XYZ scale. And finally, the max values of the random rotation. And change the value names to root X, Y, and Z. Check each value. The final addition to control the overall non-random rotation of each axis is Math Add. Then, automatically animate the Y-axis rotation using this driver. Look pretty cool, right? Now for the transformation effect combined with shader nodes. This creates a dissolve effect where the mesh disappears with small sci-fi block patterns that follow the controller object. First, set up the controller system by adding a texture coordinate node to pull coordinates from the controller object. Add a vector math length node to calculate distance and a value node named expansion to control the radius of the effect area. Next, add a math less than node to check if the distance is smaller than the expansion and connect it. Duplicate the value node and rename it edge width to control the edge thickness, and duplicate the math node, setting it to subtract to create an edge threshold. Connect these. Duplicate the math node again and set it to greater than to check if the distance is larger than the threshold. Then connect it. Add a math multiply node to combine the 2 area conditions between the expansion and edge threshold. This is the part that creates the small block effects. Add a geometry to get vertex positions. Then add a separate XYZ to split the position into X, Y, and Z. Next, add a value node named block size to control the block dimensions. Add 3 math divide nodes for X, Y, and Z to divide the position by the block size and connect it. And then 3 math floor nodes to round down and create a grid. Connect these from the respective divide nodes. Finally, add a Combine XYZ to merge the floor results back into a vector. Create the block pattern using a Voronoi texture and connect it. Add a value node named block density to control the density. Then add a math less than node to filter which blocks are visible. Moving on, add a math multiply node to combine the edge mask with the block pattern. Add a math subtract node with the top value set to 1 to invert the edge mask. Add another math multiply node to create a solid core area. And finally, add a math add. Its function is to connect the core to the edge blocks. And the checklist clamp. Now view the results while adjusting the block density, block size, expansion, and width so they align perfectly with the Geometri Node transformation effect. Don't forget to subscribe, like, and comment so that this channel can grow and produce more tutorials. Also join my Patreon community. You can download animated logo project files and other assets. Really appreciate your support. Next, adjust the shader material on the transformation effect in the Geometri node to match the car material. Duplicate the shade and add the UV map attribute node. And in the Geometri node, add the material set and realize instance. Continue by animating the transformation effect using scale keyframes on the empty controller and adjust the timing and graph keyframes. Increase the number of sci-fi blocks to make it look denser and more complex. Now animate the car in the opening with a pop-up bounce animation. This will make the transformation effect more dramatic at the start and less stiff. Please follow the process. From here, we'll create the ground surface using Mesh Plane and Displace Modifier to create a mound effect. Add a vertex group to limit the area affected by the effect. Now, target the vertex group. Locate the ground folder and add an empty object as the ground animation control. Control animate the empty object with the transform location on the y-axis. This will make the car appear to be moving on the ground. Import the rock and plant objects to create a more vibrant and varied look. Place them in a folder Add the scatter on surface modifier and target the grass stone folder. Adjust the position and number. Then, use masking and texture paint to limit the scatter area. Next, import the logo SVG frame, wings, and text to modify them into 3D and 2D logos. To follow this tutorial to the end and get a more complete version of the logo animation, please continue on my Patreon. There, you can find the full tutorial and project files for download. Thank you for your support.